Hello everybody, this is Alex Voss, your professor at TVE course, and today we're going to talk a little bit about television. Now, television has been around for a large number of years. At first we had a system developed by John Longines Baird in 1928, and he also produced the first color system back, and then it was mechanical. And at the same time, Sarnoff at RCA was trying to perfect or come up with television, and of course his engineers were telling him that all electronic television was impossible, and so he didn't go ahead and proceed with all electronic television for quite some time. But there was somebody named Philo T. Farnsworth who was sort of independent, but he actually very intelligent, and surprisingly so. While all these engineers from Stanford and from Ivy League colleges were telling Sarnoff that you couldn't have electronic television, Philo T. Farnsworth, who I think was just a high school graduate, actually made the first working all electronic television system in California, in San Francisco. And he did that in 1928, or actually 1927. And it was a very interesting story because at that time Sarnoff was interested in all electronic television, and he actually sent Vladimir Zorkin to spy on Philo T. Farnsworth and try and figure out how that system worked, and one of his secretaries, he sent her to look at the system. And basically television is, his form of television was where you had a scanning beam that would go across some sort of photo pickup tube using the properties of certain chemicals like cesium oxide that would interact with light to produce an electrical charge. And if you scanned across the image plate, as you would if you were reading a page, and then turn that into an electrical signal that would vary depending on how the light was falling on the plate. And then that signal could then go down a wire and then go to a device which had a scanning beam that hit a phosphorus coating on a tube, and that would also be more or less intensity of the electron beam depending on the light that was received at the pickup tube, and it would make light and dark spots on this phosphorus coating on a CRT, cathode ray tube, to produce a reproduction of the image. And so that was the very first television in electronic form by Philo T. Farnsworth. And basically television is always talked about in the form of scan rates, scan lines, color fields, and things like that. The first primary television system in the United States, it was before NTSC, but they had an NTSC system, which basically is now known as 480p, or 480i, excuse me, which means 480 lines interlaced. And basically you used interlaced scanning back in those days because the electronic circuitry could not keep up with doing 480 lines of progressive. As a matter of fact, the original NTSC color or black and white system had 525 lines, and 45 of those lines were in the vertical blanking interval. And so it took that many lines, 45 lines, for the scanning circuitry and the old tube-type televisions to catch up to the point where you could make your first visible line. It would then do 480 lines of video. Of course, half were in one field, half were in another field. Go to the bottom and then start up and do the 45 lines in the blanking interval. You also had some space in between each horizontal line for the sync circuitry to catch up again. Now, we have like 1080i, which is 1080 interlaced, and that just means the number of vertical scanning lines, or 720p, which is 720 lines vertical progressive. And so it's basically, when you say 1080i, 720p, 480i, you're talking about the number of scan lines vertical. The original standard def, again, is 480. High def is 720 or 1080. And of course, there's higher levels than that. But broadcast television, 1080i still. And so one of the most fascinating things about it was, in the early days of television, CBS came out with a system of color TV which was sequential. And they actually used mechanical filters that would spin in front of the camera and spin in front of the picture tube to make the color. They had some dramatic defects with that, where they some had big drums of color filters that would spin in front of the picture tube. And several of those would fly apart, tearing up apartments, blowing apart sets and so forth. So the CBS system also had a big problem in that it was not compatible with existing black and white systems. And so Sarnoff had his engineers come up with a way of making a compatible color system, which was an NTSC color system made by RCA. And so we're going to show you a historical film. And so it's a great public domain film. Hope you enjoy it. Thank you.
Television and motion pictures are alike because in both, a series of still pictures is flashed rapidly before your eyes. So rapidly that the memory of each picture lingers long enough so that it blends with the next picture and the object of the picture appears to move. And now let's see what makes a picture a picture. Look closely at this one. Closer still. Let's use a magnifying glass. Here we see that the picture is really made up of thousands of tiny dots arranged very close together. But normally our eyes don't notice the dots, especially when the picture is being moved. This fact helps to make television and motion pictures possible. Television is simply a way of sending these dots from a transmitting station and putting them together to make a picture on the screen of a receiving set. Here's the way it works. Inside the television camera is a magic electric eye called the iconoscope, one of the most important parts of which is this sensitive plate called a mosaic. It is a rectangular piece of mica covered with billions of tiny photoelectric cells arranged something like this. The scenes being televised go through the camera lens and fall on the photoelectric cells. Some of the cells receive lots of light, others very little. Each cell, according to how much light it gets, builds up a corresponding electrical charge. These charges collectively make up an electrical image on the mosaic. These cells with their electrical charges are scanned by a stream of electrons. The scanning beam skips every other line and returns to scan the remainder of the picture, completing 30 pictures a second. Each picture is composed of 525 individual scanning lines. An electrical impulse is released each time this stream covers a group of the photoelectric cells. Each separate impulse travels from the sensitive plate of the iconoscope in sequence over wires to the transmitting station, where it is then sent out into space to be picked up by aerials connected to television receivers. Here the electrical impulses are carried to another magic tube called the kinescope and are used to control another stream of electrons which bombard the face of the kinescope, which is really the viewing screen. When the beam strikes this fluorescent screen, each electrical impulse is changed back into a spot of light. In other words, each spot of light picked up by the mosaic of tiny photoelectric cells in the television camera creates a corresponding spot of light on the receiving screen. It moves back and forth so rapidly, actually more than 2.5 miles per second, that a complete still picture is formed almost immediately. The quick succession of 30 pictures a second produces the apparent motion. That is why the pictures we see on the screen of our television receivers seem to move. Television has come of age. Here, for instance, is a reproduction of one of the first images received on a television screen. Compare that crude picture with these of today, and you can judge for yourself how far along the road to perfection television has traveled.
The turning point came in 1923 when Dr. Zworykin invented the iconoscope. This tube, after years of further development, became the image orthicon, the electronic eye of the modern television camera. In 1929, Dr. Zworykin and his associates announced the first successful electronic kinescope, forerunner of today's television picture tube. The circuit was complete. all electronic television was achieved. It worked. How? The lens of the television camera acts like the iris of the human eye. It gathers in the light rays and focuses them on a mosaic of light-sensitive material that is built into the picture tube. The light-sensitive material converts the light into electrical impulses, a reaction varying with the strength of the light. The optic nerve of the camera picture tube is the electron beam, controlled by electromagnets. The beam scans the picture, which is on the plate, in rapid sweeping motions from side to side, from top to bottom. When the beam hits the image, it loses varying amounts of electrons and then bounces back to the opposite end of the picture tube, where it is amplified millions of times. It is led off to the transmitter in the form of electric current. The signals are broadcast as radio impulses into space. Heart of the receiving set is the kinescope. Here, the action is reversed. The stream of electrons, synchronized perfectly with those of the camera tube, literally picture information on a chemically treated screen line by line. The glow is bright when the beam is strong, less bright when it is weak. Thus, the picture is reassembled. 1931. Atop the Empire State Building, the National Broadcasting Company, a service of RCA, erected the transmitting antenna for experimental television station W2XBS. Now, RCA's technicians and scientists tackled the next goal, improvement of picture quality. Hitherto, using a mechanical process, the best that could be transmitted was a crude signal of 60 scanning lines. RCA turned to the new science of electronics, discarded the mechanical spinning disc, and soon doubled, tripled, then tripled again the scanning lines. Now television was really on its way. In 1937, television strode out of the studio with mobile vans developed by RCA and NBC, versatile, self-sustaining. New eyes, new vision for the world. A man could sit at home, yet his eyes could scan the countryside. A bright new era dawning, a new dimension in communications. Distance reduced to microwaves. Walls, barriers, mountains erased. Television, the ultimate triumph in man's search for sight beyond the range of the human eye. 1939. Television is ready to make its official public debut. The setting could hardly be more perfect. The New York World's Fair. Its theme, the world of tomorrow. And the world of tomorrow became the world of today. The RCA exhibit building, where on April 29, 1939, David Sarnoff stated, "We have added radio sight to sound." NBC cameras probed, explored, scrutinized. Viewers watching the 3,000 television sets then in New York saw the first president ever televised, Franklin D. Roosevelt, officially opening the world of tomorrow. Via television, the viewers toured with the King and Queen of England through Pavilion and Midway. Day by day, television produced new adventures, new vistas, new excitement, new thrills. NBC presented the first baseball game ever televised, August 1939. 1940, the nerve-tingling drama of a national political convention, the first ever televised. Philadelphia and New York were knit together by the electronic miracle of television. Radio relays, pioneered by RCA, and the telephone company coaxial cables, wiped out the horizon as the far limit of telecasting. Still in the trial and error stage, television began studying its own future as a tremendous new medium of entertainment. The first programs were simple, unpretentious, proving grounds for technicians, cameramen, directors, writers, and performers. Slowly, the know-how was gained. Bit by bit, creative imagination began to give form and substance to the new art form called television. (1941), a fateful year, war, and the beginning of a 4-year blackout for commercial TV. And television enlisted for the duration. Research went forward at war tempo. At RCA's David Sarnoff Research Center, Princeton, New Jersey, 24-hour shifts explored every corner of the new world of electronics. RCA electronics scientists and engineers made important contributions to the development of radar, sonar for submarine detection, the sniper scope that made it possible to see a target in darkness. Thus, the progress of perhaps a peacetime decade was compressed into 4 short years. 1945, the war over. After 4 years of unparalleled war effort, denial, sacrifice, the American public hungry for the rewards of peace. And television, with its promise of endless hours of enjoyment, entertainment, was part of the peacetime dream. RCA, although by far the leading producer of television sets and television tubes, realized that the future health of the industry required the vital bloodline of competition. So, in a move without precedent in American industrial history, it opened its blueprints to licensed competitors. This was the shot in the arm the industry needed. Television came of age. In the NBC studios, the cameramen, lighting experts, set designers, writers, directors were experiencing, studying, learning the new techniques of a great new medium. Programming was better, more varied, more entertaining. (1949), an historic television first, a presidential inauguration. As Harry Truman took the oath, the event was carried over the 16-city NBC television network, extending from Washington north to Boston and west to St. Louis. Television was moving with giant strides, and in less than half a dozen years, a flip of a switch in master control could send the television image coast to coast. A dynamic industry employing more than 1 million. Television, an unparalleled blending of science and art, invention and engineering, private incentive and public service. By television, American business has found a most effective advertising medium, and in turn, advertising has provided the resources that sustain the standards of programming and permit the never-ending research that is the heart of the television industry. Television servicing alone has become a major industry, employing nearly 100,000 people. Yes, in little more than a wink of time, television has entered our homes, our lives, imprinted new silhouettes on our skyline. And all this has been just the beginning. There was still another dream to be realized, still another dimension to be added. Black and white television had been the herald. It put millions of TV sets into our homes, built hundreds of TV stations, created an industry, an art, a public service, an exhilarating component of our American way of life. It provided the foundation for the next giant step forward. Color. This is a world of color, and the men of television long dreamed of capturing the full paint pot of nature and brushing it on the screen. How could it be done? It was not an easy triumph. Color. Color, the touchstone of reality, the vivid, pulsating miracle that gives substance to shadows. Beauty, grace, and enchantment to a picture. Problem: how to harness a stream of electrons for color. Early, General Sarnoff had set forth the fundamental goals for color television. First, it must be all electronic. Second, it must be completely compatible. These were the goals. The road was long, difficult, but it led to one of the historic inventions of our times, the RCA tricolor television tube, the tube with the heart of a rainbow. The lens of the color television camera collects light rays in full color from the scene being televised. Within the camera, an ingenious system of mirrors breaks down the light rays into television's three primary colors: blue, green, and red. They are focused through the lens system to the special camera tubes provided for each primary color, and the primary color signals thus produced are simultaneously processed for transmission. By the miracle of compatibility, color programs can be seen on standard black and white sets without any change or adjustment. Color receivers, which can also pick up standard black and white broadcasts, decode the color information and apply the picture in all its vivid beauty to the tricolor tube. The world of color. Color captivates attention and brings the beauty of creation close to home. Color transforms the commonplace into the beautiful. It makes the humdrum memorable, gives new power to advertising.